Hello, everyone, and welcome to another Directions Mag Geospatial webinar, today sponsored by our friends over at EOS Positioning. I'm Barbara Duke, Managing Editor here at Directions Mag, joined by our webinar producer, Lynette Qualia. If you have any questions about your connection, do drop us a note in the chat. We'll do our best to help you. We encourage you to stop by directionsmag.com and check out more feature articles, daily news, and of course, catch up on all those webinars that you've missed. We are excited to welcome our talented panel today. Will Rockwell from the city of Sarasota, Zach Petix with Palmetto Engineering is joined by Sarah Albin and Jean-Yves Latour from EOS Positioning, and also a little shout out to Emma Hardy. She's hanging out with us as well. We're excited to learn how we can improve our GPS, GNSS data collection workflows. So Sarah, we will kick it over to you to get us started today, talk about our agenda and what we're going to learn. Welcome.
Wonderful. Thank you for that introduction. Thank you, everybody, for making time for this webinar today. EOS Positioning Systems is the Canadian manufacturer of the Aero Series GNSS receiver. So if you've heard of that, we've got a couple people on the call today from EOS. I just wanted to start by, again, thanking you and thanking Direction Magazine for putting on this webinar. Today, we have a lot of good content, so I'm going to try and talk as little as possible in order to pass this on to our main presenters today. We're going to start with Zach Petix of Palmetto Engineering, and Zach is going to tell us about how he created a data collection solution that was able to work not only in a pandemic, but in a historic heat wave in the Arizona desert. And from Zach, we'll pass the baton to Will Rockwell of the city of Sarasota, Florida. And Will's going to tell us a little bit about the history of the city of Sarasota, how they were collecting data in the past, and how the pandemic actually offered an opportunity to revisit data collection and create a solution that was so easy to use. They call it grandma-proof, so a grandma could use it, a lifeguard could use it. From Will, we're going to bring Zach back on, and we're going to also bring on our CTO at EOS Positioning Systems, who is Jean-Yves Latour, and you'll have a chance to ask the three of them any kind of questions about data collection from the basic to advanced. So any questions that you have, please bring those then, and certainly put them in the chat prior to that. But we're going to kick off right before Zach with a poll.
It looks like winning is they are brand new, or that they have heard of it. Fantastic. They're in the right place, right, Sarah?
That's awesome. Yeah, we're super excited. We'll kind of tailor some of how we talk about the solutions to the folks who are new. And certainly any kind of question you have, ask us, because you've got a great crowd here. So to start that crowd, I'm going to pass it over to Zach Petix of Palmetto Engineering.
Well, good afternoon or good morning to everyone, and thanks for attending. My name is Zach. I'm with Palmetto Engineering and Consulting, and just a little quick background about us. We're a engineering and telecom solutions provider. We have offices in South Carolina and also in Little Rock, Arkansas, and we're an Esri business partner, and we work kind of uniquely. We are we work with our customers and our clients, but we also are our own consumer of products and information. So everything I'm going to share with you today is kind of an unbiased, real-world scenario of probably many situations that most of y'all find yourself in. A little bit about our project. The situation was we were contacted by a client to do a inventory in the Sonoran Desert of Arizona. And the particular client was the Tohono O'odham Utility Authority. This is a tribal utility, great group of people. Unfortunately, they have been trying to migrate from different mapping systems and CAD environments into more of a collaborative environment. They knew about how much electrical distribution and transmission assets they had in their system, but they weren't really sure. And so after a little bit of consulting, we decided that we would go out there and collect their system. And initially, you might ask, well, Zach, what kind of idiot goes out into the desert and shoots in the middle of the summertime? And I just want to let you know, I'm that idiot. We basically got caught by the coronavirus to go out there and to conduct this solution. Back in our planning stages, we were going to go out. We were going to basically utilize Survey 123 and ArcGIS Collector to go out and do a decimeter accurate collection for their system, and we were also going to conduct inspections of assets at the same time. And usually our plan was to go out and to bring our own devices, and we would collaborate with different contractors and different crews through the process. And just, on our first initial review, we figured we could get about 100 locations a day using Survey 123 and ArcGIS Collector, using iPads and Android devices. And we were going to pair those with multiple different GPS units. And, through the project planning, we thought, 110 days in the field to collect that. And that was kind of the situation I found myself in early January. Of course, COVID hit, and when it did, it backed us up by 2 months. And we found ourselves in the early summer of the southwestern desert. And we really quickly found out that that the environment was more than we had planned for. And what really had happened was we found ourselves in the desert with 115-degree heat. We were in open terrain, and the tribal entity there is a free grazing range, which means that they have barbed wire fences and hedgerows everywhere. So a lot of the assets were not easily accessible. They didn't have roads going to probably 60% of the assets in their system. And to make things even worse, being on the border, we were, we had border patrol issues to check in with. Cactus, there's a wonderful wood out in the Sonoran Desert called greasewood, which is, it really looks like little pieces of iron, and it can puncture and penetrate pretty much everything. So we found ourselves in a really just brutal environment. And I have to say, of all the places I've ever worked, it was one of the most brutal environments. Not the hardest job, but definitely one of the most brutal environments I've worked in. What we really wanted to do was we didn't want to miss our deadline. And we found out when we got out there that we were getting only about 50 shots a day. And it became really a race against the clock. And with COVID, we weren't able to stay on the reservation. We were driving in and out of Phoenix and Tucson, Arizona. So our workday really shrunk to about 4.5 hours before temperatures got so hot that everything was shut down. And we were in this race against time every day, a race against the sun. And so as we got out into the field, we realized that our equipment and everything that we were using was not going to work. The devices were shutting down at about 95 degrees. We were trying every kind of gimmick that we could find. I say gimmick, cooling pads and fans and everything, and just it really became a struggle. And even with all the devices that we were using, iPads, iPhones, multiple devices, trying to streamline those collections really just became such a chore. And my guys in the field were telling me, Zach, while we're waiting for the device to acquire our location, while we're filling out our forms in Survey 123, every second it's like an eternity. And we really realized very quickly that we had made some assumptions about the environment in the collection that just weren't going to work. And one of them was an over-reliance on air conditioning in vehicles, and we weren't able to use and rely on the air conditioning in the vehicles to help maintain the equipment. In this particular picture right here, I wanted to show you the inspector is sitting here collecting assets, but if you look in the background, you can see the vehicle is probably 400 yards from the collection site. And again, what was happening is even in the air conditioning, the device was overheating before we ever made it to the location. And so again, it was just a race against the clock. What we decided to do was to swing our operating hours earlier and earlier and earlier in the morning. But even then, we realized we were still not collecting any more than that 50 to 60 shots a day. So what we decided to do is we needed a solution. And I was telling the guys that we worked with, you know, certain teams were able to collect more assets than other teams. And we had kind of a myriad of solutions out there. And what I found out from the guys was that they really wanted, we had to have the high accuracy GPS, but they wanted equipment that was easy to port and carry, especially if they were going to be on foot going through tough terrain. And then it had to have really fast acquisition times. And that the other issue was that it needed to be rugged. And what we found out from about 4 or 5 different crews was that they were gravitating towards using the EOS units simply because the fast acquisition time initially was what was why they were using it. But then we also found out that, you know, with the terrain and carrying all of this equipment, you know, that was basically the preferred solution. One of the great things about the EOS units is that they're portable, and you can basically order from your local vendor spare parts. So we even had basically little kits that we sent out in the field with spare parts, so we could work and use the devices and do repairs out in the field. But also the other reason I think that the guys gravitated towards the devices was that they were easy to use and they were easy to set up. And when you're sharing bring your own device type environments, you know, where everybody's using different types of devices, one day an inspector might be using his phone and an iPad, and his teammate might be, you know, using his Android device. And it was easy for them to set up and pair those devices and basically maintain our high accuracy metadata through the collection. The other solution that while we were really gravitating towards the EOS units was even in this environment with crews cycling in and out, there's plenty of documentation from the EOS websites where if I wasn't able to physically talk somebody or you know, meet with somebody to talk them through pairing the device, there was resources for them to get that information and to set up the devices. And so, as I said, we really were learning by failure. What didn't work really got set aside. And so the end solution that really kind of proved itself the most reliable in the field were our Aero Gold units using ArcGIS Collector or Survey 123. And then this was where we went back and reassessed our applications. We went through and set up pick lists. Anything and everything that we could put into our collection schema, if we could make it a drop down or, you know, remove any typing, obviously that helps speed up collections. For our inspections on the actual structure or pole or asset, we used ArcGIS Quick Capture, again paired with our gold units, and we enabled the voice activation mode where they literally could go through and set up an inspection by doing nothing more than speaking into the device. And again, the less time the device, the iPad or Android device or tablet was in the sun, the more efficient and faster we became in the field. And again, every second in the sun, you know, slows down the guys in the field. So it really became tuning our process. And I know everybody says this, you know, when you're sitting at your desk as a GIS analyst or manager, you know, what looks great on your desktop or in your test environment, you know, may not be the best solution when you're actually in the field. And I have to say, I learned this the hard way. You know, some of my initial inspectors were calling me and saying, Zach, you know, it's just, this is a little redundant or this is tedious. And you don't think about it until you actually get into the field and you realize, you know what, this information can be handled in a better way. And again, enabling the high accuracy GNSS settings using the EOS units with the Esri Collector app answered a lot of questions in the background. And Survey 123, it obviously collects the location in the background in the metadata without actually having the inspector fill out redundant information about the site. And there's a couple of other little tricks. We found out that with snapping, if you're in the field and you're and you have snapping enabled, there's sometimes, depending on the snapping threshold, there are issues with equipment or devices or an inspection being collected and snapped on top of another one. So there's some, that's something I think if you're considering using your Survey 123 app with the GNSS receiver, going in there and testing that, seeing how that works in the field for you. Another issue is synchronization across the board with all of your inspectors. We were taking photo attachments of every point and location. And so if you turn those synchronization attachments off in the field where they're only uploading basically to the online organization or your enterprise, that helps speed up and reduce the amount of time that the crews will spend syncing. It'll also help with the guys. They won't have quite as much information on their device, so the device will tend to work a little bit better. And then one other point I really wanted to nail down was training. A lot of our guys in the field were new to GIS, new to digital applications. And while they knew how the app worked, and especially Survey 123, it's very intuitive. On Collector, there is a repeat collection button. There is a copy and paste button. Even though this functionality works very similar, it's not exactly the same thing. And once I was able to go and train the guys on the difference between copying and pasting records versus repeat collection, we saw a huge upswing in collections. So again, the training with your guys, training with the apps, I can't stress that enough. That really enables your crews to go and hit the ground running. Getting them used to syncing, getting them used to QA/QCing their information at the end of the night via web maps or via the GIS model. And finally, like I said, putting this thing together with an accurate GPS receiver, I found that our collections and the quality of our collections became much, much better. And I have to say that when you're doing high accuracy collection and with the EOS units, because I think the crews knew that we were managing things on a decimeter accuracy, the level of attention that they paid to collecting those assets in the field went way up. And again, I would attribute that to the fast acquisition time and the precision of the device. The crews simply just aren't spending a lot of time orientating themselves in the map. They know that where they're standing and where that device is what's being captured. And it was an interesting side effect. Like I said, the accuracy and the details went up once we started using these the high accuracy GPS and receiver metadata solutions. And then finally, and I think this is what everybody really wants to know about, is what happened? What were the final results? And part of the results that we found was that the guys who are using the EOS units were basically out collecting our other crews 3-to-1. And it seems like that's not really possible when you're going from 50 collections a day to getting 140 and 160 collections a day. But again, I would attribute that to training, to tuning those applications, to really diving into the workflow. One of our crews, and again, a very brutal environment. By the end of our collection schema, we're averaging, 140, 160, but one of the crews actually collected 360 locations in one day. And when we were reporting back to the client and to our engineering directors, they were asking me, and this is why I had this little screenshot for you. They were asking me, how is that even possible? How is 360 points even humanly possible? And everybody said, well, there's obviously they're making shortcuts, or they're not collecting, they're skimming through it. And no, that wasn't the case at all. We really were getting hitting those peaks of 360 locations. Initially, I thought we were going to miss our deadline by 2 months, but like I said, after going in and repairing with the EOS units and putting those units in the field, we were able to make our deadline in time. Initially, we thought there might have been about 680 miles of distribution line. We found, obviously, they had underreported. We got about 710 miles of distribution collected, over 90 miles of transmission. In all, when I took the screenshot of our dashboard, we had collected right at 12,000 points. But even on our follow-up collections, I think we're now around 1,300, and that's through the on-site QA/QC process. So again, the proof is in the pudding, and that is putting the right solution in the guys' hands, training them, getting them out there, and getting them very comfortable with the application. I really can't stress enough the importance of going through and setting up anything and everything that you can to make the collections go faster. The guys in the field are really working hard, and they're varying levels of competency at first. And so having that training and having the time to tune the application, maybe having 2 or 3 revisions or passes at it before deploying to the field, really is the difference. And again, if we were ever to go and find ourselves in this kind of situation, I feel like anybody could take, learn the lessons that we learned about going out into the field. You really are as good as the equipment that you take out there with you. And again, not to say anything bad about all the other devices and options you have out there, but the proof for us was the 3-to-1 collections and the EOS units. We really just couldn't have been any more pleased with the results we got. And the great thing is that we maintained that spatial accuracy and precision throughout the collection. So it really was a game changer for us. In the future, with at Palmetto Engineering, we are right now purchasing an additional 5 units, 5 gold units, and we'll be replacing our other field solutions as their life cycle ends. But it really has been a game changer for us. And the days of having to rely on bulky, heavy equipment, has really and hard to use applications has really gone away. I feel like anybody can be successful now setting up those units. But I appreciate everybody taking time to learn about my misery in the desert. And if you have any questions, we'll be glad to answer them at the end of the presentation. And I want to thank everyone again.
Wonderful. Thank you so much, Zach. You crack me up, and those are some really impressive numbers. So we are going to, we had some good questions come in. If you continue to have questions for Zach, please enter those. And now we're going to hear from Will Rockwell about a little bit about the data collection history that he inherited at the city of Sarasota, and how the pandemic actually offered an opportunity to upgrade that. So Will, I'll pass it to you.
Okay, hello, I'm Will. I'm the GIS coordinator for the city of Sarasota for about a year and a half now, so I'm relatively new at the city. And I'm going to be going over 2 scenarios that the city is dealing with in terms of GPS collection. And so city of Sarasota, we are on the west coast of Florida. We have a standing population of about 60,000. But then when snowbird season comes around, that roughly doubles to about 120,000 in the wintertime. So we do have, aside from myself, we do have 3 other GIS analysts. 2 of those are dedicated to utilities. And we're going to be talking a lot about utilities today. And GIS is under the IT department. We do have an enterprise license agreement with ESRI. And we primarily use Survey 123 and Collector when doing field collections. So for our utility asset collection, we do that in sub-centimeter accuracy with Aero Golds. We also use sub-centimeter accuracy for our drone ground control points. And we collect many other layers, some of which we're going to talk about today. And we just collect those at the sub-foot level of accuracy. So the number one project that we have going on in terms of GPS collection of the city is basically collecting everything. We are going through, and for the first time in the city's history, we are actually collecting all of our utility assets. And that is going to be, at the end of it, well over 100,000 points. In the past, the city has contracted out on a project-by-project basis, either GPS collection or asset collection, and there wasn't really a very good QA/QC process, and the data just really, well, it wasn't very good. So with these field collections, we are doing a laser offset if there's too much canopy or if there's building that's causing some interference. We're going to make sure that we get that sub-centimeter accuracy. And because we do have an ELA with ESRI, we're very heavily involved with ESRI products when it comes to displaying and analyzing our data. And so obviously any GPS solution that we choose has to fit in seamlessly with our ESRI field apps. And one of the things that we're really doing with our utility asset collection is really doing a heavy scrub of our schema, making sure that nulls aren't allowed, heavily using domains and using photo attachments. And I'm going to hit on that topic a lot when I speak today because it's really very important for your data integrity to make sure that at the end of this excruciating process where you're going out and you're collecting hundreds of thousands of points, you want to make sure that there isn't someone went out and they didn't collect something and you have a bunch of nulls or something, and then you have to go back out and hit that point again. And so in talking about this kind of failure of using contractors to go out and collect data, when I came to the city, one of the things that I really had to do for our utilities department, who is our heaviest user of GIS and GPS, is I have to break this cycle of failure. And what I mean by that is the cycle was, the city knows that its data is old and bad, so it chooses a contractor. The contractor goes out, collects data. Maybe it's good data, maybe it's not good data. They hand it over to the city. The city doesn't do anything with it. That doesn't maintain it, doesn't keep it up, doesn't do anything with it. It sits, it stagnates, years pass, and then, oh, look, our data is old and bad. And you go out, you choose a contractor. And so there's this never-ending cycle of wasting money. And what was happening was when I got in, and when Jason, my GIS analyst, when we got in and we started looking at all this utility data, and other data, there were trees that were stacked on top of one another, or very close to being stacked on top of one another. And what we discovered was when they did like a tree inventory, they put it into a GIS layer. And then years passed and they did another tree inventory. And then and rather than reconciling these two pieces of GIS data, they just merged them together and threw the points on top of old points. And so all of a sudden people start wondering why we have 70,000 trees in a very small neighborhood, and they're just doubled up. And so we have to break that cycle of failure. We have to bring it in-house. We have to implement meaningful and good QA/QC and get everything going with our ESRI setup. So we ended up choosing the Aero Golds for all of this because they do collect at a very high accuracy. And one of the things, not only were they cost effective, but it was very easily displayed vertical data. And that was a very big deal for us in our utilities department. Obviously, being on the coast, we are only a few feet in many cases above sea level. So all of a sudden, making sure things drain properly is a really big deal when you're this close to the water. So that was a big deal for us. So we ended up purchasing 8 Aero Golds to do this massive collection. We have crews out in the field every single day with these 8 Aero Golds. And that massive collection of virtually everything in the city is happening on a quarter section by quarter section basis. And we have 2 GIS analysts overseeing the collection of all that data. The next big thing that we're doing is, rather than waiting for as-builts to come in from a contractor when a building is built or when an infrastructure project is installed, is we're actually using AeroGolds to collect the infrastructure assets as they're being put in the ground. So when our utilities inspectors are on site, they actually have some of these AeroGolds, and as the manhole is being put in the ground, they step over and shoot the point. And as the valve or B-box or hydrant or whatever it is that's being collected, as it's literally being put in the ground, our utility inspector walks over and shoots the point. And they can collect, many hundreds of points a day, and we'll get into that a little bit later. But we have everything in ArcGIS Online. We shoot the points, collect the data, and it's all just visible to everyone in nearly real time. And obviously, accuracy was a very big deal for us. So getting that sub-centimeter accuracy was very, very important. And so that was our number one focus when it came to choosing our solution. The other big project that I'm going to talk about is how COVID produced an opportunity to allow us to do some field collection that ordinarily wouldn't have happened, frankly. So obviously earlier this year, COVID shut down the city hall. We had a bunch of idle city staff, and these city staff were in danger of being laid off because there's no city hall, there's no, the swimming pools are closed, the offices are closed. So you have a lot of staff that are all of a sudden they don't have anything to do. And rather than laying them off, the IT director, Herminio Rodriguez, and myself, we came up with this GPS project, because field collection of GPS assets is really a perfect social distancing job, right? You're out there, you're by yourself, nobody's around you, you're not interfacing with anybody else, it's just you and the GPS unit and the asset that you're collecting. And so we had a pool of about 15 employees. They had very low or zero tech experience. These are people that could barely operate an iPhone, and we have to get them out in the field and collecting GIS data. So we ended up renting from EOS. We rented 14 Aero 100s, which you see this picture over here on the left. That's my living room, and where I set up all these GPS units in my living room and just had them shipped there. And then you also see a box of iPhones. So we had switched from one cellular provider to another. And so I had this box of iPhones that were on the chopping block, and I was able to use those as offline data collectors. They didn't have a SIM card, but SRI Collector app still works on them just fine over Wi-Fi. And so that was the beginning of that. And now the challenge is, these people are not fit. They are not tech savvy, and you have to have them go out with these, multi-$1,000 units and get some good, results out of them. So I spent a lot of time working, designing a collector map and a process and training materials that would allow non-technical people to go out and do collector. And so I wanted to point out over here on the left, I don't know if you can see my mouse wiggling around, but this lady in the blue shirt, that is a lifeguard. This lady with the backpack on, she's a lifeguard. This lady in the dark shirt, I don't know if you can see her because this photo is kind of taken in shadow, but she actually is a grandmother. This guy over here is a desk worker for the Parks Department, and he's like scheduling events at various parks and stuff. And so now you thrust a collector and a GPS unit and then say, go walk around. So you kind of have to train them up on how to do all this. So that was the challenge. And as Zach said in the previous presentation, training is really key. You have to go over it with them in person, as of course you do, but there's going to need to be a lot of remedial training. People are going to forget, and you're going to have to remind them. And I don't know if we have time for it, but I actually made a cloud-based PowerPoint where super simple, photos of everything. Step one, turn on the GPS unit. And there's actually a photo of where the power button is on the GPS unit to turn it on. just things that a technical person takes for granted, you can't take for granted. And you really do, and I kind of harped on this before, but I want to drive it home. Spend some time on your collector map and your pop-ups on what exactly the people are going to see when they collect a feature. What are their drop downs going to look like? Set up your domains to be easy. And if you spend the time on doing that, your people are going to be that much more productive when they're actually out in the field. So the workflow is this. This is a map that everybody had on their collector, on their phone, on their iPhone if they're out in the field. It is SIMless. That means that is not a direct link to anything. You basically only sync up when you have Wi-Fi. And I told people that if you go out and you collect for 8 hours and at the end of the day you drop your iPhone down a storm drain, you've just lost 8 hours of work, so don't do that. And they seem to understand that. And when they would go home or whether they would go back to the city hall and the Wi-Fi extends out beyond the city hall in the parking lot, you could then sync up and push all of your edits to the cloud and everybody's happy. The GIS layers, just the signed GIS layer alone ended up being at over 6 gig to do the photo attachments. But what that did was that even though I was working from home, I could monitor these people's progress on a daily basis. So if someone was assigned to these grids out here on St. Armand's Island, and you could see this guy was going gangbusters. This is one of my people, and I can also attest to very high productivity with aero units because I had 2 or 3 people myself who collected well over 300 points a day. So I can vouch for that. So this guy over here, his name was Rick, and he was really killing it out over here. But I noticed that Rick wasn't taking photos, and so I was able to see in every time he would sync up at the end of the day, I would see that, hey man, you didn't take photos of this party. You go back and add the photo, or you're going to have to go back and hit it up again at some point, and make sure that you collect photos in the future. And he did, and it was great because you can kind of almost do this almost real-time QA/QC. I'm not their boss. I couldn't really yell at them and make them go do stuff, but I was helping keeping them from getting laid off, so they generally listened to me. And everybody had this quarter section grid. So, employee 1 had this grid, employee 2 had this grid. And I could see when they were getting done and they would ask me for a new grid. And then I could say, okay, well, this grid hasn't been done yet. So now you're going to take this grid. And I would just kind of dole out grids that way. And everything worked out pretty well. The challenges were, in terms of syncing, some people would try to go to a Starbucks and sync up their edits, and if you have poor Wi-Fi, your syncs aren't going to do very well, or be very fast. People would get in the zone and they would just kind of go down the street and they wouldn't necessarily know when they, crossed out of their grid, and they would just keep going, and they were collecting other people's zones, and there was a little bit of QA/QC that had to happen to remove duplicate points in some cases. Some people didn't realize that you have to charge the GPS units rather in addition to charging the phone. And participation was a little iffy because some of the people, they would do this for a week and then they'd stop and then they'd start again and they'd forget. But one of the things, like Zach mentioned in the last presentation, heat really does a number on the devices. Now here in Florida, they were collecting in May and June, through May and June mostly, a little bit at the end of April. But even in those months, it was very warm, and the heat was really killing the batteries. So I actually had to go out and buy additional battery packs so people could plug in their iPhones as they were marching around. Now, the aero units themselves never suffered any heat-related battery issues in my experience. I don't think it got that hot. I wasn't dealing with desert-like, triple-digit temperatures, but we were in the high 80s and low 90s, and that was enough to really kill the batteries of the mobile devices. And I did have to give them battery packs for that. And of course, when you're dealing with 15 non-technical people, you had better be good at tech support because they're going to be asking you a lot of questions. So the results ended up being pretty good. I was able to collect 93% of what I wanted to collect before the units had to go back. Again, these were rentals. We did use my Aero Gold, so there were 14 rentals out on the field plus mine, which made 15 collectors out there. And we did a really good job overall. 93% city management was very happy with that. It would have cost well into the six figures if we would have farmed that out. And some of the employees really enjoyed it. And I even spoke with them afterwards and like, hey, anytime you want to do another GPS collection, you let me know and I'll see if I can participate. So, but at the end of the day, it was kind of the two birds with one stone scenario where we were able to keep people from getting laid off. We were able to collect lots of great data, and that just wouldn't ordinarily be able to happen without that. So all in all, it was a good success. Management's happy, I'm happy. So one of those few situations in life where everybody wins. And that is all I have.
Great, thank you so much, Will. So we had a lot of questions come in so far, so I want to get to the panel as soon as possible to get a number of questions in. So we're going to bring back Zach from the first presentation. Will's going to stay on, and we're also going to bring in Jean-Yves Lauteur, and he is our CTO at EOS Positioning Systems. So among the three of them, I couldn't tell you how many decades of GNSS and GIS experience you've got here. So any questions you have, keep them coming. And then I think I'm going to switch this to Barbary. Or are you going to ask the questions? Or okay, perfect.
Absolutely, I'm here, ready to go. So, gentlemen, welcome back. Jean-Yves, let's start with you. Can an EOS unit connect to a state's real-time connection network, such as the Iowa DOT RTN?
Yes, definitely. First, want to say good day to everyone, and thank you for participating. Any state RTN real-time network, they always broadcast differential corrections for receivers in standard formats, RTCM format. There can be some variation of MSM format, but this is part of the RTCM standard, and the RO receivers are fully compatible with those signals. And some of them broadcast more than one constellation. Most of them will broadcast at least GPS and GLONASS, but we can see that, for example, New York State DOT RTK network has added Galileo, the European constellations. And the Florida network has even started adding the Chinese Beidou constellation also. So they support all four GNSS constellations right now. So we're going to see more and more of this in the future.
Wonderful. So the next question really is for all three of you. How do you validate the accuracy of each point? Zach, maybe we'll start with you.
Yeah, we like I said, we went into the metadata for our collections, and we actually added in all of the GNSS fields. So during the collector can actually grab the metadata directly from the EOS unit. And for our collection, like I said, we were only required to get decimeter accuracy, and we set up the threshold on collector to not be able to collect a point above 3 feet. But again, we were using Aero 100s, and we ended up migrating to the golds. Even though we were out of RTK correction, we were noticing through the metadata on the daily synchronization, like Will was saying, I would go in every day and look. We were getting, we were getting centimeter accuracy in the field. And anytime that I noticed, anytime that we noticed any variations in the accuracy levels, that usually came down to an issue of vegetation, or again, we were working on the border. And my personal experience out there was that if you were getting poor accuracy, if you gave it about 5 minutes, it usually would improve. So we were very, because it was so hot out there, we wanted to make sure we didn't have to come back twice. So, when you're out there, you want to get that accuracy. And we did that on a daily basis. Again, every time they synced, we looked for those GNSS fields.
Yeah, and I can kind of echo that because not only you can really pick it up in collector. That was our primary, filter really, is that in collector you can set you know, I'm not, you know, it won't accept a point if it's beyond, you know, 3-foot accuracy, which is what I use for collecting the signs and streetlights. So you know, collector made sure that you didn't collect any points that are too wild, you know, and when you do have those metadata fields baked into your layer that you're collecting to, you can always go back and take a look at your HDOP and all that good stuff if you really want to.
Excellent. Shanice, any comments on that?
Yes, thank you. I will add to this saying that the estimated accuracies reported by receivers are what they are. They are estimates of the accuracy. They're not the actual accuracy. And then some receivers do a better job on telling the truth about what, you know, bring closer the estimated accuracy to the reality. It is, GNSS is a very complicated science, but at least what we strive to do in the receivers is to bring it close as possible to reality. But there are other factors that you need to consider also, and it's good practice for people when they first start using a receiver to go on survey monuments and just make sure that everything is okay. You might have some datum shift problems also that you might need to solve. So you want to make sure that at least you verify the unit on a survey monument, which are readily available. For example, in the US with the NGS, you have that available, and you can just quickly assess that everything is working fine, and then you can go and start your work.
Excellent. So what accuracy did you achieve for actually the whole team there?
Well, I can say for my people out in the field, we were using Aero 100s, and in unobstructed areas, you know, where we didn't have any tree canopy, even with the Aero 100s, we would collect anywhere between 6 and 9 inches, and about 10 centimeters to 15 centimeters in unobstructed areas. And then with canopy, that would jump up to about a 1.5 to 2 feet under canopy. But that was still well within, you know, our tolerance. So that was our experience.
Mm-hmm. Excellent.
And I can you know, I can kind of go speak to that too. Even though, you know, obviously my presentation here is about working at this one particular client. When we did have RTK connectivity, and we've used these units now across the country, but we were recently doing a job in Joplin, Missouri. We were getting 3 to 5 centimeter accuracy in the field, and the reason I can attest to that is that we were working alongside surveyors with control points. So it is like Jean-Yves was saying. It's one thing to be sure that your device can collect to a centimeter or you know, that kind of precision, but are you collecting on the right asset to that kind of precision? You know, if there's a datum conflict with your land base or stuff like that, you really do need to go in there and look at that. And again, that's the devil's in the details, and EOS does an extremely good job of walking you through that process, and will probably maybe even to the z-axis when you're starting to collect against an elevation model, or in the you know, in the vertical axis, you know, having that precision and accuracy is important, because you don't want to do it again. I personally believe going forward, I think the reason why the EOS units are so attractive is because utilities right now are getting ready, whether you like it or not. You are going to be collecting in 3D environments in the next 5 to 6 years. Going out and doing virtual reality collection and QA/QC in the field using some kind of augmented reality or virtual reality on a handheld device. I personally believe that's going to be the standard workflow. LiDAR collection is becoming ubiquitous, and I think the rest of the industry is catching up with it.
Excellent. So let's talk about those training. I mean, both of you in your cases here talked about training. On average, how many hours do you think per person was genuinely needed?
Well, hours, I don't even think I got a full hour per person. I basically had to train them in a parking lot and turn them loose. But having said that, that might be a testament to, you know, the simplicity of the SRI apps and just having a really simple data entry form. I collected 10 points with them in the parking lot, whether it was, you know, a sign which I had photos of, or whether it was a street light or whatever. And after 10 points, it's, you know, tap the plus button, fill out the data, hit submit. And, you know, you do that a few times with them and they got it. And I think if you just try to make it as grandma proof as possible, and you take out as many variables or unknowns as possible, then you're good. You know, you can't stop people from, you know, forgetting where they are or you know, having, you know, trouble remembering the charge of the GPS unit. But when it comes to actual data collection point, I didn't really require much training on site. But I did make training available to them. Like I made a training video so that they could watch it, you know, later on exactly what to do. And I just kind of videoed myself taking a point.
Kudos. That's great news for a lot of people, I'm sure. So Zach, back over to you, and out in the desert, how long were your acquisition times? And in comparison, how long were those times, and what would be a reasonable weather situation?
Right. So we our acquisition times usually were about 30 seconds or less, depending on you know, the satellite array and our location. We were working in some mountainous areas and stuff, so we might not have a full access to the horizon, you know, but I would say about 30 seconds. And again, when your devices are going to overheat in about a minute in the Arizona sun, 30 seconds seems like a lifetime. And so I can kind of promise you, it really was that fast. And, you know, there are settings inside of Collector, and we used 3 different apps in the field. We used Survey 123, we used Collector, and then we used Quick Capture. And, you know, depending on how you set up the app and the personnel using it, you know, some guys have a little, you know, because they're sitting there filling out a form or whatever, there's more time for the GPS unit to cook off while they're collecting. And then as they close the collection, for instance, when you open up a collection in Collector, as you're filling out your documentation or your pick list and filling that out, you can recollect at the end of the collection. So it actually reaccurizes. So the GPS is cooking off the whole time. And, you know, 30 seconds was about, you know, about average for us.
That's great. Jean-Yves, we've got a few questions for you. What GeoID model are you using to get that sub-centimeter vertical accuracy? And can the EOS calculate a projected vertical elevation on the fly?
Yes, I mean, the GeoID models, basically what they do is that when you're in a specific horizontal datum, you apply a GeoID model and it gives you the autometric height we call in the vertical datum, but it's per country. For example, in the US, the vertical datum is called NavD88, and you use a model, which is the GeoID, currently is the GeoID 18, but prior to that it was the GeoID 12B, to convert your GPS elevation to that vertical datum. And we do that for a few countries. So it depends again on your country, where you are. You select the proper datum, and you have to receive corrections for your position to be in the proper horizontal datum, because a vertical datum is tied to your horizontal datum. So yes, we do support GeoID models in our series. Wonderful.
And I've got a question for you about the new Esri Field Maps app. What's your perspective on that? Well,
the Field Maps will replace basically 5 applications in the long run, but the first 3 that will replace, and Esri has a planned release on the week of October 26th for Field Maps that will include the functionality of Collector, because Field Map is based on Collector, is built from Collector, and that will add Explorer and Tracker. And next year they are planning to add Workforce and Navigator. But field map starting point again is collector code base and it inherits all the functionality of collector. And customers will not need to migrate to a different app. They only have to download field maps and sign in with all their Esri credentials and start using it. And we are already supporting field maps. Field maps already supports all the arrow receivers in the current beta state, so people can register and try to beta in the early adopter program from Esri. And also our solutions for laser offset for collector and also for underground locators are already compatible with field maps. Our customers can start using them today.
Wonderful. That is great news. So a couple more questions for you. Someone is, I'm sure, excited about this opportunity and wondering what the gold unit cost. And then we've got another question for you about location profiles and the use of mixed coordinate systems in collector.
Yes, perfect. The cost of the receivers, I honestly don't like to give cost because we sell worldwide, and then if someone is in the Middle East, and there's transportation cost and then exchange rates, it's a little bit difficult. But the prices range from about $2,000 US to about $8,000 US, just to give you an idea. But the best would be to inquire from our website and fill out the contact form, and you'll be directed to a nearest dealer wherever you are in the world. And the other question, I'm sorry, Barbara, was?
Yeah, they're wanting to know about location profiles and the use of mixed coordinate systems in collector.
Yes, you need, and that's not just for collector. Collector has the on-the-fly data transformation. What is extremely important is when you have a coordinate, you know in which datum you are. So you can have one point and a set of coordinates expressed, for example, for the US 983 2011, and on the same monument, you can have the same set of coordinates expressed, let's say, in ITRF datum 2008. So they're two different sets. So it's extremely important, for example, when you're doing WAS, you're doing differential correction using the WAS signal, the receiver will output coordinates in the ITRF data with current epoch of this year, with the velocities of the technical improvements at this year. So it's important that you do your proper on-the-fly data transformation in collector so that when you receive these coordinates, you go into the web mercator if you want, it's already translated. If you're on the other end, if you're connected to an RTK network, I can say that most RTK networks, not to say almost all of them, are in 983 2011 in the US, except for some places in California where they have a specific epoch for the data. And you need to apply a location profile going from 983 to your web mercator, the datum in which your maps are published in collector. So it's extremely important to take good care of that. Otherwise, for example, you would be off, you can be off as much as about 3 to 4 feet compared to your map. So you would see I have a shift. But a good way to detect those datum shifts is that all of your points will be offset by exactly the same vector if you want. So it's a good indication that you have a datum shift, that something went wrong in your profile. And there are resources on our website also to show you how to set them up in collector.
Excellent.
Barbara,
Excellent.
Barbara,
So,
I'd like to add to
yeah.
that. The one of the things
Sure.
that you do when you start using high accuracy GPS is, like Jean-Yves said, you find out parts and sections of your system that were not collected correctly or that you thought were corrected, through the QA/QC process. So as Jean-Yves said, the devil's in the details of setting up those datums, those vertical datums, standardizing all of that information in your GIS department, making sure that you actually check the devices and when I say the devices, the iPads, the Android devices, any of these maps that you're using, if you have datum conflicts in there and don't resolve those issues before you deploy to the field, you will exaggerate those inaccuracies. So there's a lot of setup that you really need to take care of. The great thing is that there's documentation from EOS and from Esri to help you with that. So if you're not comfortable with doing that, I wouldn't let it or dissuade you from going forward. It's a great time to accurize your model before you go out to the field.
Excellent. Well, unbelievably, we are out of time. So thank you so much. So many great questions, folks. So they will not go unanswered. The team over at EOS Positioning, as well as our speakers, we're going to share all this information with them, and they will follow up with you personally. So keep an eye out for those connections. I know that they are eager to answer every question, but we're just simply out of time today. So thank you for being here. Remember to keep an eye on your inbox. You'll get a recording as well as an attendance certificate. And we appreciate your opinions on the survey on the way out. Special thanks again to Zach, Will, and Jean-Yves, Sarah, and Emma for their expertise and support in the process with the webinar. Just great work today. We hope that you will go make it a great day. Tell a friend about EOS Positioning and Directions Magazine, and we'll see you again real soon. Thanks, everybody.